We've already learned how to solve linear systems by graphing and by substitution, and today we're going to look at our third and final method called elimination. Before we get to that process, let's look at these first two equations. I wonder what would happen if I combined these two equations and wrote a third equation that represented their sum. In other words, if I added the like terms in each of the equations to get a third equation, what would that look like? So you can see that my x's are vertically aligned, and if I add 3x and x, I'm going to get 4x. And if I add the 3y and subtract 2y, I'm going to get 1y. If I add the numbers, 3 plus 4 is 7. So I get this third equation, and I wonder what the relationship is among these three equations. So I'm going to go to Desmos and look at a graph. Here's a graph in Desmos of those first two equations, and there's no surprise that they intersect in exactly one point. And if I touch that point, then Desmos will tell me what that point of intersection is. It's at 2, -1. Now I want to also graph that third equation that we came up with by adding these together. So I'm going to type that in. And that line shows up in purple, and what you notice is that it has exactly the same intersection as the first two lines that I had. In other words, all three of those equations share that single point, 2, -1, and that would be a solution to that system. Now, finding the equation 4x plus y equals 7 didn't really get us any closer to the solution to the system made up of our first two equations. We could have gotten that solution by just typing those in and finding the intersection. So why are we interested in adding the two equations together? Let's look at example 1. 3x plus y equals 6 and x minus y equals 2. If we look carefully at our y's, they have opposite coefficients. I have a plus y in the first equation and a minus y in the second equation. So if I add these equations together, 3x plus x will give me 4x, and the plus y and the minus y are going to cancel each other out because that equals 0. And then on the other side of the equal sign, 6 plus 2 is 8. So the advantage here is that I eliminated the y variable for the moment, and that allows me to solve for x. I can divide both sides by 4, and x is equal to 2. Once I have a value for x, I can take it to either of the original equations up here, substitute 2 for the x value, and then that will help me find the y value. I'll put it in the first equation, 3 times x, but I know x is 2, so I'm going to substitute that in, plus y is equal to 6. If I multiply 3 times 2, I get 6, plus y equals 6, and subtract 6 from both sides, I get y is equal to 0. So the solution to this system, by eliminating one of the variables first, is going to be x is 2 and y is 0. Elimination refers to the fact that I'm eliminating one of the variables by having opposite coefficients so that I can solve for one variable and then use substitution to solve for the other variable. Sometimes, like in example 2, we don't have opposite coefficients in our system already, but we can make that happen. We can multiply one or both equations by a number that will give us opposite coefficients, and it doesn't matter if that's for x's or y's. If I look at my x coefficients, I have a -10x and a 5x. If I were to multiply the second equation by 2, then I would have opposite coefficients on my x values. So that's what I'm going to do. I'm going to keep my first equation exactly the way it is. I'm going to multiply both sides and every term in my second equation by 2. 2 times 5x is 10x. 2 times 4y is 8y, equals 2 times 9 is 18. Even though these equations don't look the same, they represent the same line because one is just a multiple of the other. They have all solutions in common. Now when I add these two equations together, the x values are going to cancel out to 0. I can add the y's together. 8 plus 3 is 11y, and add the numbers together, and I get 11. Now to solve for y, divide both sides by 11, and y is equal to 1. Once I've found the value of y, I can go to either one of the original equations and substitute that value for y to find the x that goes with it. I'm going to substitute into the second equation. So I have 5 times x plus 4 times y, but we know that y is 1 is equal to 9. So 5x plus 4 equals 9. Subtract 4 from both sides, and 5x is equal to 5. Divide both sides by 5, and x is equal to 1. Now I know the x value and the y value of the solution to that system. Remember that the variable you're trying to eliminate has to have opposite coefficients. Not the same coefficient, but opposite coefficients. So one is positive and the other one is negative. Pause the video and multiply one of these equations by a number that's going to allow you to eliminate one of the variables. It doesn't matter if you eliminate x or if you eliminate y. So pause the video and work through that, then come back and let's see if we pick the same one. I decided to multiply the first equation by -2 and get opposites on my y coefficients. You might have chosen a different variable to get rid of, and that's perfectly alright. Either way, we should get the same answer. When I eliminated my y's, I found that by adding the equations, 3x is equal to 0, which means that x is equal to 0 because 0 divided by 3 is still 0. Then I took that value for x back to one of the original equations. I used the second equation. -0 for the x minus 8y equals -8. And then I got -8y equals -8. Dividing both sides by -8 gives me a y value of 1. So our solution on this system should be the ordered pair 0, 1. The worst case scenario is when we can't just multiply one of the equations to eliminate a variable. Sometimes we have to multiply both equations by a number to eliminate one of the variables. But remember, the thing you're looking for in all cases is opposite coefficients on the variable that you want to eliminate. So if I look at 5 and 3, the coefficients of my x's, there's not a nice pretty number that I can multiply by and get the opposite of one of those. Same thing for the 4 and 3 on the y's. So I just decide, do I want to get rid of x or do I want to get rid of y? So right now I'm going to decide to get rid of the x's. So I need to multiply my first equation by 3. And the second equation I need to multiply by -5. It doesn't matter if the negative is on the 5, or if you multiply the second equation by 5 and multiply the first equation by -3. As long as you get that opposite coefficient on your x's, it will work out. I need to distribute the 3 to every term in the first equation on both sides. So 3 times 5x is 15x, plus 3 times 4y is 12y, and 3 times 17 is 51. Now multiply the second equation by -5. -5 times 3x is -15x. Notice how I set that up so the coefficient of my x's are opposites of each other. -5 times 3y is -15y. And -5 times 9 is -45. There are lots of places to make arithmetic errors, so use your calculator if you're in doubt about any of the arithmetic. Now you can see that my x's eliminate just like I set them up to eliminate. The 12y minus 15y gives me -3y. And then 51 minus 45 is 6. Divide both sides by -3, and y is equal to -2. Now I take that value of y back to one of my original equations to find x. I'll substitute into the second equation 3x plus 3 times y, which is -2, is equal to 9. Now I have an equation with just x and numbers. 3x minus 6 is equal to 9. 3x is equal to 15. And x is equal to 5. So the solution is 5, negative 2. It's important when you're going to add your equations together that your variables are lined up and your equal signs are lined up like they have been in all of our examples. In example 5, this is not true. My 4y is above my 4x, and I can't add those together. So I want to rearrange one or both of the equations so that my x's are in a column, my y's are in a column, and my numbers are in a column as well. So I'm going to rewrite the 4y equals 6x. I'm going to subtract 4y from both sides, which would be 0 is equal to 6x minus 4y. And then I'm going to write that underneath my next equation. I'm going to switch sides for my equal sign. I'm going to write the 6x minus 4y first, and the 0 on the right side of the equal sign. The equal sign works both ways. If 5 is equal to 2 plus 3, then 2 plus 3 is equal to 5. I can switch that order. Now pause the video and continue solving this equation, or this system of equations, now that it's been rearranged. I decided to multiply the first equation, 4x minus 3y equals 2, by the number 4. I'm trying to get opposite y's here. So I multiplied the last equation, the one that I rearranged, by negative 3. And you can see that I get x equals negative 4. Now I can substitute that back into the very original 4y equals 6x. That's the easiest place to substitute it in. And that's still a valid equation. So I substituted in there to get the y value that goes with my x. But you can substitute into any of those 3 equations that we started with. So we've talked about 3 different methods for solving a linear system. How do you choose which method will work the best? How do you know which one will be the easiest? They will all work for any system. If your systems are already solved for y, then maybe you want to solve by graphing and finding the intersection. Or maybe you want to use substitution on that. If you have a variable that's really easy to solve for, like a1y, then maybe you want to solve for that variable and use substitution. But if you have a system that already has opposite coefficients on one of your variables, then probably you want to use elimination. So there's not one right or wrong answer when you're making this choice. You just need to think about it and think about which one would be the easiest. If I go to my example number 7, I could use elimination there, but since I have 1x and I could solve for that, then maybe substitution would be my method right here. But you may think something different, and that's fine. You do need to practice with all 3 methods, however, because sometimes your instructions will tell you exactly how you should solve it. And even if you get the same answer, if your work doesn't match the method that was requested, then you may not get the problem right. Let's finish up by seeing what it looks like when we use the method of elimination, but we have no solution or infinite solutions. Pause the video and work through these 2 and see if you can interpret the results you get. Then come back and check. In each case, when I multiplied to get rid of my x's, my y's were also eliminated, so I had no variables left equal to the number on the other side. When I get 0 equals 4, I recognize that's a false statement, which means no solution, just like when we used substitution. For infinite solutions, my variables canceled out as well, but this time I got 0 equals 0, which is a true statement, which means there are infinite solutions. That result is also very similar to what happened when we were using substitution. Go do the practice. Make sure you ask questions if you have them, or at the end of the unit you need to make sure that you understand all of the methods. Good luck.